All right, in this next section, we're going to make a deep dive into each of the technical components inside the drone, because it would be like too hard for you to see. We're going to jump on the computer and I'm going to show you how you have to solder it together and what each of these parts means, or like what you have to know. So first of all, what you have to understand is like you have an ESC, an electronic speed controller, and you have like an FC, which stands for flight controller. Flight controller is the heart, the brain of the drone. That's where all the calculation happened. ESC, which is connected to FC, it actually defines how fast each motor spins. So all the 4 motors, they're connected via 3 cables to the ESC. When you look at how we call both a stack, so if we call that, for example, if you see in the internet a 4-in-1 stack, that means that you have like the ESC and you have the FC. And when you build it, it's usually ESC is on the bottom, then you have like a gap in between, and then you have the FC. And they're usually connected with 1 cable. So you can see that actually on this picture here. So this is the ESC, and you can see on each side, you actually have like 3 little things that come out here, and that's basically where you connect like 1 motor, 2 motor, 3 motor, and 4 motor. And this is like the FC here, and this cable is actually the ESC to FC cable. On all new modern stacks, you have this cable which connect both, and I highly recommend you, when you get into the hobby, just buy a 4-in-1 stack, so you don't need to think out. You just have that cable and you connect these 2 pieces. If you have to combine an FC and the ESC from different brands, that's very, I wouldn't say too advanced, but it's just hard. And if you make a mistake, you're going to screw up some other parts. On the FC, that's basically where you connect everything. The air unit, the GPS, the buzzer, all these kinds of things you connect to the FC, like here. For example, you can see you connect the GPS, the beeper or buzzer, and you have like the crossfire, which we discussed before. You connect it also there. And now we're going to explain a little bit more about what these words mean. Okay, so first of all, whenever you see now we talk only about the flight controller. When you read on the 5 controller a B-, that's for example that's for the beeper, and when you purchase a beeper, you have 2 cables, a plus and the minus cable. So you want to connect the minus, which is usually the black wire, to B-, and the plus sign you connect it to the 5-volt output of the flight controller. On this flight controller, you see multiple times that you have like 5V. V stands for volts, and that's simply because if you connect like different parts to the flight controller, you need different times like a positive output. So if you have a GPS, you see you need a 5-volt. If you have a beeper, you need a 5-volt, and that's why this flight controller has different 5-volt outputs. Here, for this like build, this flight controller is specifically designed to directly connect the air unit. But if you look at the description, you can see that there is actually a 10 volts. And the reason for that is, since the air unit requires more power, because it's like the digital system just requires more power, you need more than just 5 volts. You can read on in the description section. I'm happy to put that also in the description of the tutorial. The air unit itself needs something, I don't know the exact number, but it needs more than 5 volts. You need like 10 volts and a certain amount of amp that you can power the air unit. Otherwise, it's not gonna start up. Let's jump more. If you see LEDs, if you connect LEDs, I've never done that. Maybe you don't have to start with that. Now, whenever you see R4, T4, you can also up here in this other picture see, for example, R1 and T1. That's UART1, and for example, in UART1, you have always a RX and TX. So in this board, you see multiple UARTs. And for example, some flight controllers have UART 1 to 4, and some more fancy flight controllers, they have UART 1 to like UART 6. And whenever you hear the word UART, you always have an R and a T. And what does that mean? So R is always receiving and T is always transmitting. And because if you connect the GPS, if you connect a crossfire, or that always has a receiving and a transmitting signal. That's why for each UART, so UART for GPS, you have a UART for RX, so you always have like you always have to connect it to one of these UARTs. The order doesn't actually matter. So you can connect a GPS to UART 4, or you can connect it to a UART 2. What I recommend you is, whenever you work with the digital system, use the UART 1 for the air unit, unless you already have like this here ready to connect cable option. Some of the flight controller they have, you can just plug in with the cable directly the air unit, then this is already reserved for UART 1. Otherwise, UART 1 or 2, you can also then take UART 2 to connect the controller, because then, and with the controller I mean the crossfire. And okay, so now we dived into UARTs. And let's see what else you need to know. If you see M1 to M4, M1 means motor, and M1 of course means motor 1, and you have 4 motors. That's why you have M1 to M4. And if you look up here on the description, if you have that ESC to FC cable, you always see like number 1, 2, 3, 4. That means that from flight controller you have 4 cables going, 1 for each motor. Just that you understand that. If you see G and D, that means grounding. That's always like you have the positive, like the positive input and the negative input, and like the negative would then be like the grounding, so minus. Mostly the technical components is like a black wire. Okay, now that we talked about the FC, when you wire up devices, keep that in mind. So for example, if you have a GPS, some of the GPS, what GPS always and what all the components have is they always have a G and D, a grounding, so minus. They always have a positive input like 5 volts or 10 volts, so a black and a red cable. And then they always have an R for receiving and a T for transmitting. This GPS we can see here now has some additional features. It's like SCL and SD8. That's when you have like barometer or like more advanced measurement tools. You can have like also connect these two to the flight controller if you have that option. For example, you see like this GPS. I also have another option up here to quickly show you that. So that's a very simple one. You have 5 volts grounding, RX and TX. But some of the GPS are more fancy, and you're going to have 2 additional wires. Then that's for SCL and SDA for barometer. You can just simply then use these outputs on the flight controller as well. And then important, a RX on a flight controller goes always to the TX of the component you want to connect. And the TX on the flight controller goes always to the RX of the component, and that makes sense. The one thing on the flight controller which is like transmitting, so T, needs to be connected with the receiving on the components. So transmitting goes to receiving, and receiving goes to transmitting. So it's always like the opposite. The same is for a crossfire. It's actually absolutely the same. You have a grounding, so minus. You're going to have 5 volts. Which is positive, and you're going to have a TX and the RX. So TX on the crossfire will be connected with RX on the flight controller, and the RX or R5 is connected to the TX on the flight controller. Make sure when you connect these, we said before you have different UARTs. So the GPS, when you have the RX and TX, make sure that on the flight controller you always connect it to the same number. So for example, R1 and R1 and T1 is then reserved for crossfire. R2 and T2 is then reserved for the GPS, and so forth. It doesn't matter which UART you choose for which component, as explained before, but what is important that you connect them the opposite way. Yeah, you can here see. A UART 1 always contains, as I said, a R1 to T1. The next thing I want to show you is, this is like a close-up from ESC, electronic speed control, and you can see like 1 motor, 2 motor, 3 motors, and 4 motors. when you solder the motors, it doesn't matter which cable from the motors go to which pin, but these three, so one unit like this one needs to be connected to one motor. This one needs to be connected to the other one, and so forth, 3 and the fourth. Like, don't connect the cable like here, here, and here from one motor. Stay within the triplet. And inside the triplet, it doesn't mean how you connect the cable, because the way you connect your cable just defines how the motor spins. But I'm going to show you later, there's a specific tool how you can define in which direction the motor spin. So just connect each motor to each triplet, and you should be fine. These two big pins there, this is actually for the battery. So that's the main input and you can always see there is like a minus and a plus. So minus is black and plus is red. And you always connect one of these pigtails where you have the battery, you can like basically solder these to the flight controller. When you solder, I can explain that later, but keep in mind, if you work on big parts like motors, if you work with this part, go to 400 degrees Celsius when you solder. When you work with closer parts like on the flight controller, go with 370 to basically save 30 degrees, which, yeah, to have less heat on the smaller electronic devices. Basically also when you solder what I see is people either put like first the soldering iron and then like the liquid metal thing, or put first the metal and then the iron. You have to basically do it together. So first you're gonna heat it up a little bit, but then you it's like a simultaneous movement that you want to actually let it flow it down. That's really important. Then the next thing is, you can see some of the flight controller, when they come, they already have a condensator. And how does a condensator look? This is like a condensator. These look like this. Some of them are already wired to the device, and if not, on the condensator, and that's really important, I'm going to show you on the picture, you can see this goldish thing, and you see a minus. So a condensator always have a minus and a positive output. And when you go then to the flight controller, make sure that the minus of the condensator goes to the minus of the board with the black cable and the minus of the battery. And the positive, the red one, that's where you connect from the condensator, the positive part. If you have to solder a condensator by yourself, it's really important that you see there's like these like legs. But what you want to do is like to keep the efficiency high as possible, you want to clip the legs as close as possible to the condensator, because you're going to lose you're going to lose more and more efficiency if you go down. So what you want to do is you just clip it as close as possible, and then you solder literally a black cable and a red cable. You place your condensator wherever it fits, and you then connect it to here. And what I recommend you first, you're going to solder this part, so this pigtail. You're first gonna solder this one, and then once this is like really hot, you can still connect the small cables from the condensator, because this one needs way more energy, and once this is like cool, you can easily connect the condensator. But my recommendation there is really clip off the legs as much as possible. Use a black and a red cable, which you usually have, because there are always more cables when you order parts, and then just place it somewhere. Okay. On the condensator, by the way, you see this micro F, that's microfarad, that's the capacity of the condensator. If you go with 6S battery, I would recommend you to get 1,000 microfarads. And to also explain you what a condensator does, imagine it like a wheel which you spin. And if, for example, like if you have like these water wheels, and you always have like a momentum, even if you stop, it keeps spinning from its own gravity and weight. And you can basically imagine the same thing when you have a condensator, because the battery not always gives you the same energy, and it's basically stored that energy in the condensator. So when there is like a little lag in the battery, which is just for a few seconds, the condensator still provides that missing energy. So it's like a storage for energy. That's why it's extremely important, and your flight behavior is much better. Especially, for example, if you want to go into racing, you can almost see that they put as many condensators as possible to the drone, because you can like go way longer with full throttle than without. Let's talk about the Crossfire. I explained before there are two types of Crossfire. It's like the nano version, that's the cheap version. You see one chip, and then you have the diversity. You basically have two chips. That's the $60 version, and that's like the $25 to $30 version. This is like 95%, this is okay. Unless you want to build, like I said, a super glider with extra 2 antennas. And you see here, you have like basically one antenna, and that's the UFL connector. I showed you that in the antenna tutorial at the very beginning. And on this one, you can see basically there are 1 and 2 antenna. That's exactly because this thing decides which antenna is basically transmitting and receiving. So it's basically changing depending on what is better. And you see basically here again the same structure. You have a grounding, a minus, you have a 5-volt positive, and then you have an output and an input. It's sometimes the description is confusing, but what you have here, it's like a TX and an RX. And when you buy this component, there will be a little paper where it shows you what is R and what is R and T. And I also put one of these images how you connect into the description of the tutorial. But literally what you have to do is connect the red cable, connect the black cable, and then you have a RX, for example, here, and you connect it with the TX of the flight controller, and you have a TX here, and you connect it with the RX. And it's the same for this Crossfire. Forget all this description here. You have a black cable, a red cable, and you have the channel 1 and the channel 2, which is the TX and the RX, which you need to connect the opposite way. Forget that channel 3 up to 8. That's if you, to be honest, there is a reason behind. I've never studied it, so I cannot tell you much. I'm sure some of you know more, but for me it was enough. All right, next part. If you have the air unit, it looks like that. Here again, to recap, same. You have power, and you see here, that's what I talked before. You need more than 5 volts. You need between 7 and 17 volts. That's in this area it operates. You have the black cable, which is the minus. You always have the RX and the TX as before, but now you're going to have 2 additional cable. One is an additional minus. That's the signal grounding. So that's another black, could be another black wire. Here it's just brown. And then you have like this DJI HDL. But on most flight controller, you call it the SBUS. So you will always find this SBUS connector. Let me show you here. That's exactly the 10 volt, that's the positive, the grounding. We said we have a TX and the RX. We have the antenna grounding, which I said before is the other minus. And then you have this SBUS connector, it's here. On some flight controller, it's just like a pin here, which is described as SBUS. So whenever you connect the air unit, you have this yellow cable, and you have to connect it to the SBUS of the flight controller. That's super crucial here, and that's why I highly recommend to go with this. I'm a big fan of T-motor stacks, and the reason why is you connect the ESC and FC in one little clip, and then you already have this entire setup to connect the air unit directly, and you can see the SBUS, the grounding, and everything you need to know. It's already there, nicely laid out for you. You don't have to think much. When you go with the cheaper, lighter option, you have basically the Vista, and that's how it's called. And if you get it, the cables are not wired in. You have to wire it in by yourself. You don't have to take it apart. Just be careful, put your temperature to 370 degrees Celsius and start wiring it up. You can go on Google like I did, Castic Vista, and you see most of people have already defined the order. So you see again, VLiPo is basically the 10 volts or 12 volts output on the flight controller. You're going to have so that's the plus. You can have the grounding, which is the minus. You have again the RX and the TX, which you need to be connected to the opposite side. So again, the RX going to the TX on the flying controller, and the TX goes to the RX of the flying controller from the same number. So RX here and TX go to RX1 and TX1, or TX1 and RX1. Then you have the signal grounding, which is similar to that one. It's again a minus cable, a grounding. And the last one is like the SBUS, which I said before. For the Vista, you have to know you can directly connect it to a 6S battery. For the air unit, you can only connect it to a 4S battery. What does that mean? When I showed you before the flight controller, let me go back to that picture. That means here the air unit is directly connected to the flight controller. And what that means is the minus and the plus sign is plugged into the flight controller directly. But with the Vista, you have a different option. You can directly connect the minus and the plus on the ESC output where the battery and the on the condensator is soldered in. So literally, where this cable is connected and where the condensator is connected, you can wire the minus of the Vista, so the grounding of the LiPo, to the minus there, and the positive input from the air unit to the positive of the battery, because that Vista module can handle up to 6S battery, what is a good thing. And especially then it's important that you have a condensator, that you never have a lack of energy. All right, so let's recap that quickly. So we said your UART always has an RX and a TX. You can see that nicely here. UART 5 has an RX, UART 5 has a TX. And you always need a UART when you have like receiving and transmitting components, like a crossfire, like an air unit, or if you have like a GPS. If you have like a buzzer, and yeah, let's quickly talk about buzzer. Buzzer is like a tiny little thing you can buy. It has an extra battery like this big. You connect it to the drone. Once you crash it and the battery comes off, the buzzer has like battery for like 3 weeks, and it starts beeping after like 2-3 minutes, and then it does a beep every like 20 seconds for like 3 weeks. So it's easier for you to find it, especially when you go to and it falls into high grass or in a forest. It's really good if you can hear like where the drone is beeping from. And yeah, sometimes you also see a BEC, like BEC. That's a voltage converter. So it's basically electronic voltage converter. So it basically takes the high energy and it reuses down, for example, to 5 volt 2 amps and 10 volt 2 amps into voltage area where you can like where the different components operate. One thing which is really, really important, if you have like 2 different types of flight controllers and ESC brands, like say a T-Motor flight controller, but the ESC you have from Holybro, and you connect the flight controller with the ESC, what I suggest is take the ESC, put in the cable you have from there, and then basically you go from like here you have ESC FC cable, but it could be that the order is different on the other flight controller. So what you have to do is you have to manually take out the cables and put them back in the order of the new flight controller. You have to be really careful, and the most important thing what you have to consider there is make sure that you connect the ESC, when you connect the ESC to the FC, that it goes to the VBAT, so the positive input. If you, for example, go from the ESC to the 5 volt input of the flight controller, you're going to destroy everything, because the 5 volt input can only handle up to 5 volt. And if you come in with the full battery voltage, you see the voltage converter cannot handle it, and you're going to destroy it. So, and what you do then is you literally, because all the 5 volts output, they are kind of connected. So you would destroy all of that and everything connected. So if you have a crossfire connected to 5 volt and you basically connect the flight controller with the ESC to the wrong connector, you literally destroy all the components. So keep that in mind.